So in the one on the left, this is a system that has 3 variables, then 2 variables, then 1. This is called a triangle system because of its shape. Okay, but the method that you use to solve it is called back substitution, which you're going to see again when we get into 7.4. So it's just important to know what that is. So I'm going to work, in this case, bottom to top. I'm going to take the 3. I'm going to plug it into the z. So I'd get 2y minus 3 equals 7. 2y would equal 10. And y would equal 5. And then I take the z, plug it in, the y, plug it in, and I get 3x plus 5 plus 2 times z equals 8. And then 3x plus 5 equals 6. Or sorry, not plus, equals 6, plus 6 equals 8. 3x plus 11 equals 8. 3x equals negative 3x. And x equals negative 1. And then you've got all of them. Negative 1, 3, or negative 1, 5, and 3. Questions on that? Easy stuff, right? Just be really careful. It would stink to get a question like that wrong just because your positive, negative sign gets mixed up, something like that. All right, number 2 is your system with 3 variables, 3 equations. So this is the one that obviously takes a little bit longer. We're going to pair them up and cancel out a variable. And then get the third equation you didn't use the first time with either of the other two, cancel out the same variable, and then use those new equations together using elimination, which is what we did in 7.2. So if I number these, let's say this is 1, this is 2, this is 3. Somebody give me what their plan was. What did they do first? Because you're going to get different answers. You did 2 and 3 and canceled out what? The y. Okay, so 2 and 3, canceling out the y. So you didn't have to change 2 at all. 5x plus 4y plus 22z equals 0. But the x, you had to, the third one you have to multiply by negative 2. So this is negative 2 times 3, which would be negative 8x minus 4y minus 38z equals 0. And now I'm combining these. I get negative 3x. These cancel, which was the plan. Negative 16z equals 0. And this is new 1. Okay, so then you had to do the first one, right? So which one did you match it with, 2 or 3? 3. And honestly, it doesn't matter, right? Because you have to change both of them either way. So if I want to look at this one and this one, in order to cancel out the y's, which is what you have to do again, you'd have to multiply one of them by positive, one of them by negative, and the top one by 2, the bottom one by 3. So which one did you make negative?
The negative 2.
Okay. So we're going to do negative 2 times 1, and I get negative 8x minus 6y minus 34z equals 0. And then positive 3 times the third one, 12x plus 6y plus 57z equals 0. And now I'm going to add these, 4x, these cancel, plus 23z equals 0, and this is new 2. So then I use those two, negative 3x minus 16z equals 0, and 4x plus 23z equals 0. And I've got to cancel out a second variable. Obviously, it's easier to work with the x's than the y's. So I'm going to multiply this times positive 3, or then the z, sorry. This, nope, other way around. I can multiply this times 4 and this times 3. And I get negative 12x plus 64z equals 0. Positive 12x plus 69z equals 0. Yep.
What are the negative 16, like when we did those times 4 negative 16?
Oh, yes, thank you. This is negative. Cancel these out. And I get a positive 5z equals 0. Divide both sides by 5. And z equals 0. There's my first one. God bless you. God bless you. And then I have to take and plug that in where? One of the new ones, right? If you plug it back into an original one, there's still 2 unknowns. So it doesn't matter which one. Let's just say I grab the bottom one. 4x plus 23 times 0 equals 0. 4x, this cancels, equals 0. And again, x equals 0. And then I got to take those two and plug them back in where? into one of the original ones. Again, doesn't matter which one. So let's say I grab the top one, 4 times x, which is 0, plus 3y, which is what we don't know yet, plus 17z, which is 0, equals 0. Cancels, 3y equals 0, and y equals 0. And then, not that it matters because they're all the same, but the order, because they're not always going to be the same, you'll probably never get a 0, 0, 0 again. The order would be 0, 0, 0, x, then y, then z. Questions on either of those? So up to this point, we've done with 2 variables, substitution and graphing, and then elimination, and then we added in the 3 variables with the triangle system, and then the regular 3 variables, 3 equation, okay? And then we talked about word problems mixed into those sections. So that, in addition to what we're about to do, which is partial fraction decomposition, will be what's on your 7.1 to 7.3 quiz. So we're going to finish. There's a couple of slides to finish off the notes that you had from part 1, and then we're going to get into part 2. So this is still multivariable linear systems, and you'll see at the end like why it pulls back into this section. Otherwise, it's kind of out of place till we get there. But it's what's called partial fraction decomposition. The idea behind partial fraction decomposition is we are used to seeing something like what's here on the right and being asked to simplify by finding a like denominator and then combining them into one and getting the answer that's on the left, right? That's something you've seen since Algebra 1. What we're doing now is working in reverse. You're going to get a question like what's on the left, and you're going to have to break it down into its multiple fractions. That, when added back together, would give you the one on the left. So we're going to start baby step our way in. This is the explanation, which I think is super confusing. I tried to make it like go from math speak to English on this slide. Okay, but even that, you're going to have to go through the process in order to understand it. So the very first 3 steps are going to be to factor the denominator of what's ever there, if it's not factored already. Sometimes it's already going to be factored. Then you're going to split the fractions for each term in the denominator. So for each factor that you have, after you factor, you will have that many fractions on the right-hand side. If there's 2, then there's 2, 3, whatever it is. And then the numerators are going to get filled in with these placeholders, which are constants. We're going to say A, then B, then C. If there were 2 terms, it'd be A and B. 3, A, B, C. 4 terms, A, B, C, D, for as many as there are. We're going to start there, and then we're going to figure out how to fill in those A, B, Cs. So this first example just says, write the form of the partial fraction decomposition of the rational expressions. And then it says, so read it carefully because it saves you a lot of work. Do not solve for the constants. So we're just saying what A, B, and C are. So the first thing I'm going to do is look at A and ask yourself, can you factor the denominator? What's the answer? Yes. How would you factor that? Take out the x, and I get x times x minus 4. Is that factored completely? How many factors are there? 2. So I need 2 fractions. One's going to go over x. One's going to go over x minus 4. The first one gets the a. The second one gets the b. And why is it 2? Because this is one factor, and this is the second factor. So I would say as many parentheses, but you don't always have parentheses. As long, it's however many factors when you separate it out. Yep.
Do you always like add them together?
Yep. Yep.
The first one always gets the A.
The first one always gets the A, the second one gets the B. And honestly, after we get past this example, it doesn't matter what you call them because you're going to fill it in with a number eventually, okay? All right, then I go to B. Can you factor your denominator? No, it's already factored for you. How many factors are there? 2. A over x plus B over x squared plus 3. Super easy, right? Sorry to bring trouble, because now we're going to do this. So 1, 2, and 3 are exactly the same, okay? Factor the denominator, split the fractions, give them the A, B, C, D. Now we're going to figure out what gets put into those A, B, Cs. So once you do what we just did, which was up to there, then you're going to look at just your numerators, okay? And you're going to go section or fraction by fraction and figure out from the right-hand side what is missing from the denominator that we just factored out to compare it to the original one. And you're going to multiply the numerators by what's missing. Again, this will make a lot more sense when we work through. But the idea is if you get stuck, hopefully you come back here and it will refresh your memory. Then once you do that, you're going to find the value of x that's going to cancel those variables out one at a time. So we want to first cancel out a, then we want to cancel out b, c, however many there are. And by doing so, you end up solving for the other ones. And then you'll take at the end whatever a, b, c is, which will be numbers, and you'll plug them back into what you got at the beginning. All right, so again, start the same way. Look at your denominator. Is it factored? Yep, already factored for you. You're welcome. Now I'm going to split it. How many fractions should there be? 2. A over x minus 3. B over x plus 5. We're good there, right? Okay, so now you want to compare your new denominator to the initial one and figure out what's missing. So what's missing from the first one to x minus 3? X minus 5, or plus 5. And that's what you're going to multiply the numerator by. And then go to the next one. What's different between x plus 5 and x minus 3 and x plus 5? X minus 3. So the step that would actually need to be happening here that we're not showing is you can't just change one fraction, right? Like you can't just change part of it without changing the actual value of the equation. What we would normally do is multiply both the top and the bottom by the same thing. So I would multiply both the top and the bottom by x plus 5, and then both the top and the bottom by x minus 3. And then all of the denominators would be the same. Does that make sense? So we're going to skip that step because it's work we don't need to do. Once we get all the denominators the same, then we can take all the numerators and set them equal to each other. So I would say that 6x plus 14 would need to equal a times x plus 5 plus b times x minus 3. So again, the step we're not showing because we're going to skip it, but it's what would have needed to happen, is we would have multiplied both of these by x plus 5, both of these by x minus 3. Then all the denominators would be the same, which means I can set the numerators together. With me so far? Okay, so now my goal is to one at a time cancel out the a and cancel out the b. How would you cancel something out? Good. I want what it's next should be 0, yes? So I want to figure out what could I plug in for this x value to make that become 0, because if I multiply a times 0, it goes away. So negative 5. So the first one I'm going to do is negative 5. And then I want to repeat that process for b. So what would I plug into x to cancel out the b? Positive 3. So it goes into every x that's in my equation. On the left here, it's going to be 6 times negative 5 plus 14 equals a times negative 5 plus 5 plus b times negative 5 minus 3. And then I'm going to simplify it. So negative 30 plus 14 equals negative 5 plus 5 becomes 0, which cancels it out. That was my goal there. B times negative 8. I get negative 16 equals b times negative 8, and b equals 2. So in canceling out a, we've solved for b. Now I'm going to repeat that whole process with x being 3. So 6 times 3 plus 14 equals a, 3 plus 5 plus b, 3 minus 3. I get 18 plus 14 equals a times 8. 3 minus 3 becomes 0, and it cancels out my b. 32 equals a times 8. And a would equal 32 divided by 8, which is 4. With me so far? So my answer is going to be what we started with the a and the b, but now we're plugging the a and b values back in. So I want to take what we had up here and replace the a with a, which is 4 now, over x minus 3, plus b, which is 2, over x plus 5. And if you have time, which I'll be honest, you're probably not, because between 3 variables, 3 equations, and these, you're going to fill your time. Okay, but if you had time, if you're a speedy worker, you can always check this answer by working backwards. So if I wanted to take this and make it one fraction, that one fraction should be this. So my least common denominator is going to be x minus 3 and x plus 5. I'd multiply the 4 times the x plus 5, the 2 times the x minus 3, simplify it, and you should get 6x plus 14. So I would actually try to get this to have a least common denominator, which would be the product of these, right? So x minus 3 times x plus 5. And then this one's missing the x plus 5. So I'd get 4x plus 20. This one's missing the x minus 3. I'd get 2x minus 6. And then combine your like terms. 6x plus 14 over x minus 3, x plus 5. And that is your initial question. Mm-hmm. So once you get to the end and you have a negative coefficient that would be at the top, you want to pull that negative out front. So instead of the negative being on the 3, instead of it being plus a negative 3, think about it, you'd never see that when you were writing out fractions. You'll pull that negative out front. So if the first one was negative, like if 4 was negative, sometimes they'll even switch that, so the first one's always positive, but you'll pull the negative out front. You're going to see in a moment too, like sometimes you'll get fractions as numerators. You got to pull the denominator of the fraction out. You can't keep a fraction within a fraction. Questions up to this point? Feeling good? Understand? Because it's about to get worse? Yeah, we're good? Okay. Oh, yeah. I'm going to work this one through with you, okay? And then it's going to get even more fun after this. So what's the difference between, well, first of all, let's start. This time we've got a factor, right? How do you factor that? Take out the x, and then x squared minus 4, and then factor it again, x plus 2, x minus 2. So this time, you get 3. Okay, that's the first fun part. So it's a over x plus b over x plus 2 plus c over x minus 2. And it does not matter if you're like a person that when you factor difference of 2 squares, there's like 2 different types of people. One does the minus first and one does the plus first, okay? There's no right or wrong there. What will happen is whichever variable you solve for, the b, whatever has to go with x plus 2 has to be with x plus 2. Whatever has to go with x minus 2 has to be, the order does not matter, okay? All right, so the first step's the same. Second step's the same. Go through, multiply out what's missing. So from x times x plus 2 times x minus 2, the a is missing both the x plus 2 and the x minus 2. Then you look at b, x plus 2, this is missing the x and the x minus 2. And you look at c, this is missing the x and the x plus 2. And again, you want to write out all your numerators. So x squared plus 12x plus 12 equals a times x plus 2 times x minus 2 plus b x times x minus 2 plus C x times x plus 2. With me so far? So if they are all different, which is where we're at now, it's the kind of the same process. Each time you cancel out one, it's actually going to cancel out 2 at a time if you do it right. It'll cancel out 2 at a time, leaving you with the third. Pick a new number, cancels out 2, leaves you with the third. Pick a new number, it's going to cancel out 2, leave you with the third. Okay? In a minute, you're going to see what gets jazzy is if the constants, if the factors are the same. Okay? So let's say we want to cancel out A. There are 2 options to cancel out A. What's one of them? X could be positive 2, yep. Or it could have been negative 2. If I plug a 2 in here, it's going to cancel out A. Plug a 2 in here, it's going to cancel out B. And it's going to leave me with C. So by canceling out A, I actually cancel out A and B. Do you see that? And I'm going to end up solving for C, which you'll see in a minute. I'll work through that. But then I would go to the next one. Now let's say I want to cancel out B. Again, I have 2 options. What are my options? 0 and 2, but we already did 2. We'd end up canceling out both A and B again and solve for C. So I have to use 0 because I need to be able to cancel out to eventually solve for A. This one would solve for A. And then I go to C, and I have 2 options again. What are they? Negative 2 and 0. I've already used 0, so I'm going to have to use negative 2. Make sense? Yeah? Okay, then the fun starts, right? Because now we get to go through and actually plug it in. So everywhere there's an X goes the 2.
How does canceling out B make you guys 0?
If you put a 0 here, it becomes B times 0, which is 0 times X times 0 minus 2. X minus 2. Mm-hmm. Oh, this is 12. Test? I haven't even made it yet. Quiz? You'll get like a partial fraction, like maybe 2 or 3, because you're going to see what's going to happen next. Yeah. All right, so to get to the C, I plugged in 2, I got C was 5. To get to the A, we plugged in 0, we got -3. To get to the B, we plugged in -2, and we got -1. Everybody with me so far? Yeah? All right, so now my answer, A, which is the 1 over the x, gets the -3, so this would be -3 over x, plus B goes in the top of the x plus 2, which means the negative comes out front, -1 over x plus 2. And then C gets the 5, +5 over x minus 2. And I said it before, but let's say we had switched this order because, again, you're factoring. You're going to determine your order. It's totally fine. As long as the -1 goes with the x plus 2 and the 5 goes with the x minus 2, the order here does not matter. Okay? It's just that the right numerator has to go with the right denominator. Question so far? So it's just that one is the same process. It's just that you have an extra variable, so it's a little bit more work, right? But it's the same process. This thing, which is called repeated factors, okay, is an entirely different process. Well, not entirely different. First couple steps the same, but then from there it doesn't work. So when a factor in the denominator occurs more than once, each factor has to be accounted for. Meaning if I have an actual, once I factored, if I have a factor that is raised to a power bigger than 1, then I have to do it differently, okay? And think about why this happens. If I had, let's just say I had like 1 over x squared. Now, if I broke x squared down into its factors, it would be what? X and x. So if we follow through what we would have been doing, I would get a over x plus b over x. I'd end up with a number in the top, blah, 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 go through the work, right? And then I go to check it, right? And if I were to take this and squish it into one fraction, what's my denominator? What's the least common denominator of x to the first and x to the first? Just x, right? It doesn't work. So if the factor, whether it be a single term like x or an expression like x plus 2, is raised to a power bigger than 1, so if I had x plus 2 squared or x plus 2 to the third, then you actually have to work your way up using the exponents. So you have to do that variable or term to the first power, then to the second, to the third, however many terms there are. So in this case, you have x squared. You have to account for x to the first and x to the second. If it was x to the third, I'd have to do x to the second, x to the third. Okay, and then the way we solve them is entirely different because you can't cancel these out. If you cancel out one, you're going to cancel out the other. You'll never actually eventually solve for them. So the method I'm going to teach you for this can actually be done on the ones we just did. Okay, but I think what we did was easier. You choose. Okay, you can do the same method for all of them. But what we just did can't be done on these. All right, so I'm going to walk you through. First of all, this one is don't solve. Just figure out. So look at the difference between this denominator and this denominator. First of all, the first one's not factored yet. We've already done this. We factored this one. This would be x and then x minus 4. Is there a repeated factor there? No. So this just gets your a over x and b over x minus 4. But when you look at b, okay, there are 2 x squareds plus 3. So this would be a over x plus b over x squared plus 3. Plus c over x squared plus 3 squared. So you got to build it up until you get to the exponent that's there.
Why does the c have...
All right, so the directions stay the same. It's up to you to recognize that this is going to have a repeated factor, which is done different. So if I look at the denominator here, I've got x squared and then x plus 1, which means when I separate this out, it is going to be a over x plus b over x squared plus c over x plus 1. First step the same. Well, first step would be factor, so that's the same. Second step's the same, separate it out. Third step's the same, multiply by what's missing. So this is going to get just the second x and x plus 1. This one's going to get x plus 1. This one's going to get the second x, or no, sorry, x squared. Both x's. I got to write out all my numerators. 4x to the second plus 2x minus 1 equals a times x plus 1 plus b times x plus 1 plus c times x squared. Now, I'm not going to go through the process because it's going to be wrong, but I'm going to tell you what would happen if we had done what we just did. For a, we could either plug in a 0 or a -1. And it's going to cancel a. It's going to cancel, if I did the -1, it would cancel b, but I'd be able to solve for c. When I go to b, I can only plug in a -1. That's going to cancel a and b again, and I'm still left with c. I would never be able to solve for all three. So this is why this process is different. After you get here, you're actually going to simplify the right-hand side. Distribute out whatever's there. So I'd get ax squared plus ax plus bx plus b plus cx squared. So I'm just distributing out the right-hand side. Left side is the same as it was. Yep.
Why didn't you put the x plus 1 and x?
Because the b already has x squared on the bottom. It already has both x's. So to get from here to here, the only thing it's missing is the x plus 1.
Even if it's missing.
All right, now on the right-hand side, I'm going to group together all the x squareds, all the x's, and all the constants. So this is going to get ax squared plus cx squared. They both have an x squared. I'm going to group together anything that has x to the first, so ax plus bx, and whatever's the constant, which is b. Again, left side still the same. Now, if this is a true equation, then the first term here that has the x squared is going to be equal to these terms combined. The one over here that has an x is going to be equal to these two combined. And the one that's by itself is going to equal the one that's by itself. So I'm actually going to separate those out into 3 separate equations. So 4x squared equals ax squared plus cx squared. 2x equals ax plus bx. And negative 1 equals b. From the first one, I can divide everything by x squared, and it's going to eliminate all my x squareds. From the second one, I can divide everything by x. It's going to eliminate all my x's. The last one is already solved for b. So this is why this is in this section, because what we just created is a system. The good news is this is a triangle system. So this is already solved. I could take it, plug it in here, and I get a equals 3. Then I take that, plug it in. Oh, I don't need the b. And I get 4 equals 3 plus c, and c equals 1. Then you've got all your numerators, and you can plug them back in. Once you plug them back in, so a goes with x. This would be 3 over x. B goes with x squared, so it'd be minus 1 over x squared. And then c goes with x plus 1, so this would be positive 1 over x plus 1. And then there's your decomposed fraction. All right, we're going to work through one more example. Same set of instructions. Write the form of the partial fraction decomposition of the rational expression. If you look, this is an x squared, which tells you you're going to have a repeated factor, 1 over x, 1 over x squared, 1 over x plus 2. And this is a, this is b, this is c. So from here to here, you're missing another x and the x plus 2. From here to here, you're missing the x plus 2. And from here to there, you're missing x squared. So your numerators are 9x squared plus 3x minus 1 equals ax times x plus 2 plus bx plus 2 plus cx squared. And remember, we can't do these like we were doing before where we cancel out one variable at a time. This time we're going to simplify the right-hand side. So 9x squared plus 3x minus 1 would equal ax squared plus 2ax plus bx plus 2b plus cx squared. And then you want to group together the squareds. So the 9x squared would be grouped with ax squared and cx squared. The x to the first would get grouped together, and then the constant would get grouped together. So if I did just the x squareds, I'd get 9x squared equals a x squared plus cx squared. And then 3x would equal positive 2ax plus bx. And then the last one, negative 1, would equal 2b. From the first one, I can cancel through all the x squareds, and I get 9 equals a plus c. From the second one, you can cancel all the x's, and I get 3 equals 2a plus b. And the last one, I can solve for b. I'd get b equals negative 1/2. So now, again, you're going to work backwards. This one has the b and an a, so I can actually take and plug this in to solve for a. 3 would equal 2a minus 1/2. Add the 1/2 to the other side. 3 plus 1/2 would equal 2a. This becomes 6 over 2, so 7/2 equals 2a. And then divide both sides by 2, which is multiplying by 1/2. And I get a is 7/4. Then I want to go over to the first one and plug a into here. So 9 equals a, which is 7/4, plus c. Subtract the 7/4. 9 becomes 36/4 minus 7/4. That's 29 over 4 equals c. So now I've got c, a, and b. And I'm going to take them and plug them in. The a, which is 7/4, went over the x, so 7/4 over x. Plus the b, which is negative 1/2, went over the x squared. Plus the c, which is 29/4, went over the x plus 2. Now you can't leave fractions within the fractions, so I'm going to first bring these down. And I'd get 7 over 4 times x. This negative is going to come out front, so minus 1 over 2 times x squared plus 29 over 4 times x plus 2. And then WebAssign will actually force you to find the least common denominator, the greatest common factor of your denominators and take it out. So because each of these are divisible by 2, I can take it at 1/2. 1/2, and then 7 over 2x minus 1 over x squared plus 29 over x plus 2. So the format on the WebAssign would be to take that out. For me, if the denominators are all the same, so if they each add a 4, then I'd expect to see it taken out. But for the rest of it, if it's the quiz, I'm not worried about it just yet. You could have left it like this. All right, that's the end of 7.3 and all the material that's going to be on your quiz.